Hello, and welcome to the last section of our video course Advanced Types. In the first video, we're going to talk about how to apply conditions using conditional types. Conditional types probably are not something you will write every day, but you might end up using them indirectly all the time. That is, because they are great for framework code and for dealing with API boundaries and other behind-the-scenes processes. So it is always good to learn how to use them. Let's start by looking at the following plain JavaScript code. Reading the code, it is clear to us that toUpperCase method call is save. We can tell that whenever a string is passed into the process, a string will be returned. But notice that we could also pass something like null into the function, in which case null would be returned. Then calling toUpperCase on the result would be an error. Let's now jump into a demo and rewrite this block of code with TypeScript so we can let TypeScript worry about whether we are using it safely or not. For this demo, we will use the TypeScript playground as in previous sections. All seem to be the same as in JavaScript example before, but let's now add the call to the function. As you might see now, we are getting the type error. TypeScript complains because it thinks that the result of process foo call might be null. Even though we clever humans know that it won't be, it cannot figure out at the runtime semantics of the function on its own. So, one way of helping TypeScript to understand the function better is to use overloading. Overloading involves providing multiple type signatures for a single function and letting TypeScript figure out which one to use in any given context. Let's rewrite our code to do that. Here we are basically saying that if we pass a string, it returns a string, and if we pass a null, it returns a null. The any type is ignored, but still needs to be there as per TypeScript compiler rules. Now, when we call our code, it should be working fine. You can see it is okay now when we pass a string, but we still have an error when passing null. Also, there is another use case that does not work. TypeScript won't let us pass something that is of type string or null, because it is not smart enough to collapse the overloaded signatures when that is possible. So we can either add yet another overload signature for the string or null case, or we can switch to use conditional types. Here we have introduced a type variable t for the text parameter. We can then use t as part of a conditional return type of t extends string, string, or null. You probably noticed that this looks just like a ternary expression. Indeed, it is doing the same kind of thing, but within the type system at compile time. Also, you might have noticed a compiler error here. This is the known problem and already have been reported to the TypeScript project. Soon it will be fixed. But for now, as a workaround, you may cast your return type to any, so we still will have an advantage of our conditional typing and the error will not appear anymore. As you can see, everything is working fine now. So that's what a conditional type is. A kind of ternary type expression. It always has this form. It would be the same as we said A extends B, C, demo. A, B, C, and D can be any old type of expressions, but all the important stuff is happening on the left there, in the A extends B condition. The extends keyword is the heart of a conditional type, A extends B. Means precisely that any value of type A can be safely assigned to a variable of type B. In type system way, we can say that A is assignable to B. In the next video, we're going to look at how group types using intersection and union types.